All right. Okay. Number 2E on the homework. This is what. Oh.
We were orienting the board. Yeah, we said to reorient them. Danny Brown.
Okay. This is what I want, right?
Yes.
So 1 to 7, right? What do I know?
We know that 1 to 9 is -1. 7 to 9 is 5.
Okay. We know 1 to 9 is what?
-1.
So this is -1. And what is this?
5.
So would this much be the whole thing minus this piece?
Yeah.
-6?
Did it stop? I just probably did that like that. How can it be -1?
Well, because you're talking about a distance traveled. And so that's the thing. We're not talking, it's not a number line like you think of it. And Griffin, all of you, the math has to stay on.
Okay. Sorry.
Has to.
Did stop recording thing pop down? I think it popped to the corner.
Yeah, it's up there somewhere. I did this the other day.
Okay,
And it hit on me. I'm blinking, so.
Okay. Just want the best for you, Ken.
What else?
I was 18 on 4, and then 8 and 10. 4. Yeah, 8. No, we don't.
Wait a minute. 4 what?
4B. I think I did it right, but I wasn't sure.
Okay. 4B. Isn't it the same thing as what you're given?
Yeah.
So it's just,
Doesn't matter what the letter is.
it doesn't matter what the letter is.
That's what I thought, but I wasn't.
That is correct.
For what?
4B. Now what?
Okay, 18 is mine.
Well, we can go over 6. That'd be cool. 12.
How do you do the number line thing again? Do you put the original, or what you're trying to get, and then...
Well, I just put what I knew. And then what am I looking for? So what are we doing
How
here?
does it work when you're going backwards?
Like, what are you talking about?
Like on 6B, how it goes from
6B?
3 to 1.
That just makes it,
And like, because most of the time we did like A to B, B to C, so A to C.
okay. Did you get 6A?
Yeah.
Yeah. Yes.
No?
Harrison, help me.
Isn't that just 6?
It's normal.
No.
No?
It's 1, not -1.
Wait a minute.
No. No.
All right. On number 6, aren't I looking from -1 to 1 and -1 to 3?
Yeah.
Okay. So I have -1 to 1 to 3. Right? You agree with that?
Yeah.
What do we know? This is 0. What else do I know? This is 6. So for this piece right here, is it the whole thing minus that? Okay, so what is it? 6. Everybody okay with that?
Yep.
Now, on part B, what is the difference between 1 to 3 and 3 to 1?
It's negative.
It's negative. So if I want a negative of the negative, it's the same amount, isn't it?
Yeah.
So that's B.
Oh.
Okay. And we didn't do 8 and 10, right?
No.
Okay.
Taylor, hang on.
12 and 14, do we need actual points like x and y, or is it just like x equals?
I have x equals whatever. Oh, the value for y is this amount at x equals whatever.
How do you find the x equals part?
Well, on 12, what did you get for y?
I don't know. I wasn't 100%. My calculator reset and
Huh?
-4.5.
No.
Oh.
Negative 4.5.
What?
That's what I got.
We don't use
Is that what we were supposed to use?
Yes.
Well,
By the, like, the 1/b minus a.
my calculator reset.
Here, Griff, come here.
Okay, I'm not going to tell you again to put your mask on. I am not.
And then,
Griff, come here.
You don't use the program.
Okay.
Huh?
You use the program for NINT?
Yes.
Well, you can, but it's the average, so you got to take it times 1/b minus a.
Oh, wait, really?
Oh.
Oh.
Yeah, really.
but then you said that, you put that in for Y.
-1.5.
So,
Yeah, because that.
yes, that's why.
Oh, yes.
Oh, I did.
So,
That's
So when you do the NINT,
I wouldn't do the NINT. You chose to. Okay.
How would you
well,
do it?
but that's what it says in the directions. Use NINT by the end.
Okay.
So that's what I did.
Okay.
So is that not your answer, or is that the first part?
Isn't your, what number is this?
This is number 12.
On number 12, isn't it 1/3 minus?
0.
Yeah.
3, is it 0?
Yeah.
Of the integral 0 to 3 of f of x dx?
Yes.
I got -3/2.
Okay.
Now, the question is, it says find the average. At what point in the interval does the function assume that value? So when is -c² / 2 equal to -3x? So I put c, I could have put x, and solve for x. So does, or c² have to equal 3? So what is c, or x? Square root of 3. That's that's all you have. The average value is -3/2 at x equals radical 3.
I thought it was, so the answer is radical.
If I solve that for x, yes,
I thought the answer was -3. Where'd you get -3?
that was the average value.
How'd you find it?
Did this right here.
Okay.
Now what?
So hold on, real quick. The NINT. No, it doesn't even get us.
No, we got to move on because we have to get to a certain spot by Wednesday.
On 16, do you like calculate it like?
No, it's definitely.
On what, 16?
Yeah.
On 16, I took the area of a rectangle minus a semicircle.
That's what I did.
What's a rectangle
If
though?
you want it in decimal, like,
No. I know. It's okay. Okay. I want this area, correct? Can I take this rectangle and subtract this out?
Yeah.
Wouldn't that give me the area between the curve and the line?
That's what that was asking.
Well, yes.
Just solve the area.
All right, now what? 18.
18.
Yeah, definitely.
Now, by the way, on number 16, you know, you're also finding average. So whatever I find, I multiply by what? 1/2?
Yeah.
Right? All right. Let's talk about 18 just a minute. Can we?
Please.
well, that's a lot of help. What is the tangent of negative pi over 4? I didn't ask you to plug in your calculator. I asked you what it was.
Tangent of pi over 4.
What's the tangent of pi over 4?
Okay, so,
I know that I told you no less than 20 times last year to remember that number.
it's 1, isn't it?
It's 1. Okay, so the tangent graph is 1. Actually, negative pi over 4 is in quadrant 4, so it's negative 1, isn't it?
Yeah.
So it's down here. This one is positive 1, isn't it? So it actually looks like this. What do you think you know about this area and this area?
Same.
Is the one below the axis negative?
Yeah.
Is the one above the axis positive? So what do you think the answer is going to be?
0.
Very good. Now what?
30. Could you 32, what are we doing? What are we trying to find? We're trying to find the average value of the functions in the interval. How do we need to do that?
It's average value.
Mm-hmm.
1 over 2e minus e, correct? The integral.
Mm-hmm.
What's the integral?
Integral is
1 over x dx? Bless you. Right?
yeah.
And this is e to 2e, I believe. Isn't
Yeah.
it? The derivative of what is 1 over x? ln of x. Right?
Yeah.
So I have the ln of x from e to 2e, and it's divide 1 over e. Is that right?
Okay.
This just means, when I write it this way, this is the same thing as capital F of 2e minus capital F of e. But I took the antiderivative, and this is what I'm going to plug in. That's all I've written. Okay? So do I have 1 over e? Isn't this ln of 2e minus ln of e? Are you with me?
So,
You think so?
so isn't that just going to be 1 over E ln E? Right?
Do you remember? And I'm going to make you think a minute here. From logarithms, when we had something multiplied, I could change this right here to ln of 2 plus ln of e, and then minus ln of e. That's what logarithms did. So what is this? ln of 2 over e. Now what? Processing this.
So you did.
Isn't the antiderivative of 34 the arctangent? Arctangent? Was arctangent? Derivative of arctangent? Emma?
For 20 through 30, we didn't have to multiply by 1 over b minus x, right?
I don't think so. I think
No, it wasn't average value.
And it's always minus, right? You always minus them.
Yes?
Okay, so
Where is my... worksheet is worksheet 2 on functions defined by integrals. Got it?
Yep.
All right. If I ask you, we're going to kind of look at a few together to make sure you understand what you're doing. Okay? So if we're looking at 1 on the worksheet, is that where you are? All right. So number 1 on the worksheet, we have f of x is equal to 1 over x of the cubed root of t squared plus 7 dt, correct? And we want x to be equal to 1. It asks us to find the equation of the tangent line. What I'm missing is m and y, correct?
Would you say?
M, slope,
Okay, yeah.
slope. Tell me what slope is.
The rate of change.
Slope is the derivative, isn't it?
Yeah.
Guys, this is also the derivative. So if I want slope, I plug x in the derivative. So what is m? 2. Correct?
Yep.
I'm sorry, I can't make it simpler. Now I need y. Isn't y f of x? So I need to plug 1 in place of x. Okay? So when I put a 1 right here,
Yeah.
make sure Ben can see it.
Yes.
What is the value of my integral?
0.
0. So y is 0. Now, can I write the equation of the tangent line?
Yeah.
Isn't it y minus y equals m x minus x?
Yeah.
Hold on, Miss Paul.
Wait a minute, 2x minus 2. What?
So when you plug in, you're plugging in a 1 for, how do you get 0 out of putting 1 in your integral?
Because I don't put it in my integral.
Or your,
I put it right there for that x. And if I'm going from 1 to 1, what's the value of the integral? Yes.
Gotcha.
When x is 1, y equals 1?
All right.
Oh, okay.
Number 2. 5x cubed plus 40, right? 5x cubed plus 40 is equal to c to x of f of t dt. Correct? What is f of x? F of x is in the integral. So is f of x the derivative?
Yeah.
So what is the derivative of this right here? 15x squared.
Okay, yeah.
Bless you. No. No. It would not.
How do we know that?
Because all they did was change letters. We don't care about the letters. We're not worried about the letters. Okay, part B says find the value of t. Now, isn't an integral the derivative? Yes? And what is the derivative this is this, right?
Wait,
this would go here.
Why wouldn't it go to derivative t?
Does it matter what letter?
No, I'm saying derivative of x if we're using.
Wait, I have a question. If f of t is the derivative in 5x3 plus 40, wouldn't that be the derivative? Wouldn't we have to find the derivative with that?
Okay, would you agree that's what I have?
Yes. Okay, so
Yeah.
this is what my question is. Why are we putting the derivative of the original one
Into the
Because we want to find the value of c, and that's the only way to do that. That's the only place c is, so I've got to work with the integral.
I'm just thinking derivative of t already has derivative in it. So why aren't we putting in the derivative?
I want to find the value of c.
Okay.
Okay. This part, well, okay, why don't we just listen a minute. Now, what is this? This is an integral. The value of the integral is to take the antiderivative and plug in the top number minus the antiderivative to plug in the bottom number, correct?
Mm-hmm.
So is this equal to 5x cubed minus 5c cubed?
Why is that?
Because I took the antiderivative and plugged in the top, minus the antiderivative and plugged in the bottom. Right?
Where did the 40 go?
It's right there.
But we need
There's
to
no
get
40 on that side, because the derivative of 40 is 0.
that. Okay.
So is 40 have to equal negative 5c cubed?
Yeah.
Right? So is c cubed equal to negative 8? What is c? Negative 2.
Can you explain one more time how we did that last part?
What, like this?
the
This?
on the right side of that.
Right here. How did we do that? I took the antiderivative of this, which is 5t cubed. Right? I plugged in the x minus plug in the c. Plug in the top minus plug in the bottom. That's what an integral is. All right, moving to 3. Number 3, f of x is equal to negative 4 to x of t minus 1 squared. It would help if you all were listening instead of talking when I'm talking. Yeah, I thought so. T plus 3 dt. For what values is x decreasing? Do I have a derivative?
Yes.
Isn't it true? Isn't it true that a function is decreasing when the derivative is less than 0?
Yes.
Isn't that what we just did on the last test?
Mm-hmm.
So what I want to know is, if I have this, isn't t equal to 1 and negative 3?
Why?
Because it makes the it makes the derivative 0. Like in the
But why do we care for 3?
Because the derivative is 0 when it's changing from increasing to decreasing or decreasing to increasing, isn't it?
Decreasing.
1 and 9, whatever. So
Yeah, why?
One is 0.
What?
It goes. When it's at 0, isn't it just, it's not increasing or decreasing?
Right, so I found out where it's at 0.
Oh, I see what you're doing.
So my intervals are negative 4 to negative 3, negative 3 to 1, and 1 to infinity.
Okay.
x is. That's what I'm going to find. All I'm going to find is where is it increasing, where is it decreasing. I have my intervals, don't I? So what do I do with those intervals? Derivative. You just did a whole paper, didn't you?
Yeah, that was one.
Yeah. So what number are you going to put in here?
Let's go with
Negative 3.5. This is going to be positive, isn't it?
Yeah.
This one's going to be positive. This one's going to be negative. What's a positive times a negative? So this is negative. What number are we going to put here?
Zero.
This is positive. This is positive. So positive. What number are we going to put here?
2.
Positive, positive.
Yeah.
So where is this function decreasing? Negative 4 to negative 3.
so x is -3.
No, I didn't ask you to find x. I asked you to find where the values of x is it decreasing. It's decreasing all values between negative 4 and negative 3.
Okay, so why do you need to find the 0? Why aren't you finding where it starts to decrease? Wouldn't you go one number below where it makes it 0?
No.
Why not?
Well, because what? Okay, you want me to go to
The zeros are intervals.
The-
You have to find your
the function is doing this.
Yeah.
Okay, right here it was at 0.
Okay.
So it's decreasing here.
Uh-huh.
Why would I go one number up? It's still decreasing,
Okay. Okay.
right?
Yeah, yeah. That makes sense.
All right, go to 4. This may be our last one, and then I may get you on your own.
Okay.
Look at the graph. Do you see the graph? What we know is this graph, and I'm just going to sketch it, stops right there, is a derivative graph. Agreed? Do you agree it's a derivative graph?
Yeah.
That makes a difference. Now, find h of x is equal to 0 to x of f of t dt. Agreed? Find h of 0.
0.
Doesn't that mean instead of my x, I plug in 0?
Yeah.
What do I get?
0.
0. You agree?
Thanks.
Okay. Oh, I shouldn't have written it there. I should have said h of 0. What?
So you're plugging 0 in for
For x. I'm plugging 0 in for x. Because this means in place of x, in place of this x right there, I put 0. So in place of x, I put 0.
Would it always be 0?
Anytime I didn't
Oh,
move.
I see it.
I started at 0, stopped at 0.
I have a quick question. What is that saying? Like, what is that equation saying? It says h of x is equal to.
That's your function. That's what you're getting.
Yeah, I know.
But that's just saying.
Like, what does it mean?
What does it mean?
Like, what is integral?
It means that h of x, my function, is equal to the derivative of it from 0 to x dt. That's all it means.
Okay.
That's all it means. Now, what interval of x is h increasing? Now, didn't we say it increases when the derivative is positive?
Yeah.
This is a derivative graph.
Yeah.
Where is the derivative positive?
From
0 to 6? So it's must be increasing from 0 to 6, because that's where the derivative is positive. Right? Justify your answer means the derivative is positive. Right? Okay. When is it concave up? Is it concave up when the second derivative is positive?
Yeah.
Which means it is concave up when the tangent line to my derivative has a positive slope. So when I look at this graph, right here, where would the tangent line have a positive slope? I would say all of that, wouldn't you? That's negative, right? So from this is a positive one?
Yeah.
So what is this value right here? 9? So it is concave up from 9 to 12?
Yeah.
What is my justification? The tangent line to the derivative is positive, yes. Now, my question is, let's go back to this where I can see my graph, is h of 12 positive or negative? H of 12 means, isn't my integral from 0 to 12?
Yeah.
So h of 12 means from 0 to 12. Is my area going to be positive or negative? The area between the graph and the x-axis. Look from 0 to 12. Is there more area here or more area here? Positive, so it's going to be what? Yeah, okay. So the answer to D is positive. Why? More area positive than negative. Now, when does it achieve its maximum value? Didn't we say maximum was when it went from positive to negative?
Yeah.
So what x value does this derivative go from positive to negative?
9. Wait.
6.
6. Yeah.
Yes. Yes. All right?
See you then. Holy
Then it doesn't have a worksheet.
Hope you're feeling better.